Welcome to G Fun Facts Online. Have you ever wondered why taking a pill at 8 a.m. might feel different or work better than taking that exact same pill at 8 p.m.? It's not just a coincidence, and it's not all in your head. It's a science, and it points to a hidden, powerful force ticking away inside every cell of your body, your internal clock. For a long time, we thought of the body as a machine that worked the same way at all hours. But we now know that's completely wrong. Our bodies are more like a complex orchestra, with dozens of different rhythms all playing in sync. Today, we're diving deep into the cutting-edge science of chronobiology, the study of these internal clocks. We'll explore how understanding these rhythms is unlocking a new era of medicine, one where timing isn't just a factor, it's the key to health, from personalized drugs to the microbes living in your gut. So let's get started. The first major frontier in this field is something called chronopharmacology. It's a long word for a simple, revolutionary idea, giving medicine at the time of day when it will be most effective and have the fewest side effects. Think about it. Your blood pressure, your hormone levels, even the rate at which your liver detoxifies chemicals, none of these are constant. They all rise and fall in predictable, 24-hour cycles. So why would we treat them with a constant, one-size-fits-all drug schedule? Let's take a common example: blood pressure medication. For most healthy people, blood pressure naturally dips while we sleep and then begins to rise sharply just before we wake up. This morning surge prepares us for the day. However, in many people with hypertension, this morning surge is exaggerated and dangerous. It's no coincidence that the highest incidence of heart attacks and strokes occurs in the early morning hours. For decades, the standard advice was to take blood pressure medication in the morning to combat daytime highs. But chronobiology research flipped this on its head. Studies have shown that for many patients, taking certain blood pressure medications at bedtime is significantly more effective. The medication gets to work overnight, blunting that dangerous morning surge before it even begins, leading to better 24-hour blood pressure control and a lower risk of catastrophic cardiovascular events. This isn't just a small tweak. It's a fundamental shift in how we approach treatment, and it's just the beginning. The future of this field is moving towards truly personalized timing. We're talking about creating individual chrono profiles. Think of it as a detailed fingerprint of your personal daily rhythms. This profile wouldn't just label you a morning person or a night owl. It would map out the precise timing of your unique biological processes. How would we build such a profile? First, your genetic makeup. We're discovering specific gene variations that influence whether you're naturally inclined to wake up early or stay up late. Your genes dictate the fundamental speed and timing of your internal clock. But it's not just about genetics. Your lifestyle is a huge factor. When you eat, when you exercise, when you're exposed to light, all of these things send powerful signals that tune your internal clocks. The real game changer here is technology. The wearable sensors we have today, like smartwatches and fitness trackers, are already collecting vast amounts of data on our sleep patterns, heart rate, and activity levels. In the near future, these devices could become far more sophisticated. Imagine a wearable that continuously and non-invasively monitors biomarkers, tracking the subtle ebb and flow of hormones like cortisol or melatonin in your system. This real-time data, combined with your genetic information and lifestyle inputs, would allow for a level of personalization we've never seen before. Your health app wouldn't just give you a generic reminder to take a pill. It might say, your inflammatory markers typically peak at 7:30 a.m. To maximize its effect, take your arthritis medication at 7:05 a.m. Or, your liver's detoxification enzymes are most active between 1 a.m. and 3 a.m. Taking your statin drug at 10 p.m. will ensure it is processed most efficiently, reducing the risk of side effects. This is precision medicine in its truest form, tailored not just to your body, but to your body's rhythm and time. But the orchestra of clocks in our body is even more complex than we thought. Recent research has revealed a fascinating new player in this symphony: the trillions of microbes living in our gut. It turns out, our gut microbiome has its own daily rhythm, a clock that is deeply intertwined with our own. This creates what scientists call a bidirectional relationship. It's a two-way street. Our internal clocks influence our gut, and our gut influences our internal clocks. Let's break that down. First, our eating patterns are the primary cue for our gut microbes. When we eat, we're not just feeding ourselves, we're feeding them. The composition and, more importantly, the activity of our gut bacteria fluctuate dramatically throughout the day based on our meal times. Certain bacteria that are good at digesting fiber will be more active after a high-fiber meal, while others that process fats will ramp up their activity after a fatty meal. These rhythmic activities in the gut microbiome have a profound impact on our metabolism, our immune function, and even our mood. Now, what happens when our main clock is disrupted? Think about the experience of jet lag, or the chronic disruption faced by a night shift worker. Your brain's master clock is receiving confusing light cues, and it gets thrown out of sync with the local time. This, in turn, sends chaotic signals to the rest of your body, including your gut. Your gut microbes, which are expecting food and activity at certain times, suddenly find their environment completely unpredictable. This leads to a condition known as dysbiosis, which is a harmful imbalance in the gut microbiome. Healthy, rhythmic bacterial communities are replaced by a more chaotic and often inflammatory population, which has been linked to obesity, type 2 diabetes, and inflammatory bowel disease. But here is the most exciting part of this two-way relationship. If our clocks can disrupt our gut, then maybe, just maybe, our gut can be used to fix our clocks. This opens up incredible therapeutic possibilities. Imagine instead of a sleeping pill to treat a circadian rhythm disorder, your doctor prescribes a specific type of probiotic designed to be taken at a specific time of day, or a diet plan meticulously designed to strengthen the rhythms of your gut microbiome. For instance, consuming prebiotic fibers at a time when beneficial bacteria are most receptive could boost their population and encourage them to produce metabolites, like butyrate, that are known to travel through the bloodstream and positively influence the clocks in our liver and even our brain. By modulating the gut microbiome through diet, probiotics, or even more advanced therapies like fecal transplants, we might find a powerful, non-pharmacological way to reset our body's clocks and treat the wide range of health problems associated with their disruption. As we look to the future, the applications of chronobiology extend far beyond pharmacology and the microbiome. Researchers are exploring a whole host of innovative strategies to help us live more in sync. One of the most promising areas is advanced light therapy. We already know that light is the most powerful signal for setting our brain's master clock. That's why staring at a blue light-emitting phone late at night can make it hard to fall asleep. But our understanding of light's non-visual effects is deepening. We're learning that different wavelengths, intensities, and timings of light have very specific effects on our biology. In the future, we can expect highly sophisticated light therapies. This won't be just a generic bright light box. It might be a system that uses specific, narrow wavelengths of blue-green light in the morning to provide a powerful, energizing wake-up signal, and then shifts to warm, amber-toned light in the evening to naturally promote melatonin production without you even noticing. These systems could be integrated into our homes and workplaces, creating light environments that are optimized for both our health and our performance. Beyond technology, the principles of chronobiology are poised to become a cornerstone of public health. We can expect lifestyle recommendations to become much more nuanced and time-dependent. Instead of just being told to exercise regularly, you might receive guidance based on your personal chronotype and your health goals. For example, research suggests that for some people, afternoon workouts might be best for building strength and performance, while for others, morning exercise could be more effective for weight loss. Similarly, the concept of time-restricted eating, where you consume all your calories within a specific window of 8 to 10 hours, is a direct application of chronobiology. It's not just about what you eat, but when. By aligning our eating patterns with our body's metabolic rhythms, we give our digestive system a long rest overnight, which appears to have significant benefits for metabolic health. Finally, One of the most extreme and fascinating testbeds for chronobiology is space travel. Think about the challenge for astronauts on the International Space Station. They orbit the Earth every 90 minutes, experiencing 16 sunrises and 16 sunsets every single day. This total loss of a natural light-dark cycle, combined with the stresses of microgravity, wreaks havoc on their internal clocks. This can lead to sleep deprivation, cognitive impairment, and a weakened immune system, all critical problems for someone performing complex tasks in a dangerous environment. To solve this, space agencies are investing heavily in chronobiology research. They are developing advanced lighting systems inside spacecraft that precisely mimic a 24-hour cycle on Earth, and they are implementing strict schedules for sleep, meals, and exercise to help anchor the astronauts' rhythms. The challenges of space force us to understand the absolute fundamentals of our internal clocks. The solutions we develop for keeping astronauts healthy in orbit provide us with invaluable insights and technologies that can be applied right here on Earth, helping everyone from airline pilots and shift workers to patients recovering in a hospital's 24/7 environment. Of course, despite all this remarkable progress, the journey to fully understand the intricate dance of our internal clocks is far from over. Many profound questions still remain. For instance, we know the brain has a master clock, but every organ and perhaps every cell has its own peripheral clock. How exactly do these countless clocks communicate and stay synchronized with each other? How does the liver clock know what the kidney clock is doing? We also need to better understand the full spectrum of natural genetic variation in human circadian rhythms. We talk about larks and owls, but the reality is likely a much wider continuum. What are the precise molecular links that connect a disrupted clock to diseases like cancer and neurodegeneration? Answering these questions is the next great challenge for the field. What is clear, however, is that the era of ignoring time in biology and medicine is over. We are at the beginning of a revolution, one that appreciates that our health is not just about the what, but also the when. From the timing of your medication, to the timing of your meals, to the timing of your exposure to light, every signal you send your body has a temporal component. By continuing to explore this incredible field, we are unlocking the secrets to living a longer, healthier, and more harmonious life. A life lived in sync with the timeless, fundamental rhythms that govern all life on our planet. So the next time you set an alarm, check your watch, or notice the sun setting, take a moment to appreciate the complex, beautiful orchestra inside of you. You're not just marking time, you're living it in every cell of your body. Thank you for listening to G Fun Facts Online.